Okay, this next spreadsheet is a little more complicated than the basic standard deviation model. This is a portfolio expected rate of return standard deviation model. The top part here is where I put is this where you calculate the expected rate of return on stock A and stock B. So this is simple, kind of like what that other spreadsheet model does. No problem here. But you need these numbers to then find the portfolio expected return. Just a weighted average of the individual assets expected rates of return. Okay. Then once you have the portfolio expected rate of return, that is what you'll then use down in the bottom part here to find the standard deviation of the portfolio. And the trick here, if you look in the formula, it looks basically like the normal standard deviation formula. But you can see it's standard deviation and little sub P for portfolio. The key is this term right here, this R sub PI. What this means is it's the estimated rate of return for the portfolio in state I. So this is a number you have to calculate yourself. In the spreadsheet down below, I've rewritten the estimated returns for stock A, estimated returns for stock B. Then I've assigned weights, kind of like I did up here, starting off with a 50%, 50-50 weighted portfolio, 50% in A and 50% in B. The key is this column right here, the estimated portfolio return. And it's just another weighted average. The 7.5% is just a weighted average of 50% of -10 plus 50% of 25. So if the recession state occurred and you had a 50-50 portfolio of stock A and stock B, then your portfolio return would be 7.5%. Same thing down here for like below average. To find the estimated portfolio return in the below average state, you would take a weighted average. 50% of A's plus 50% of B's return gives you 12%. So you have to calculate this column right here. And once you do that, then it's just like the regular standard deviation formula. How far does this number, the 7.5, deviate from the expected? So how far does the estimated portfolio return in each state deviate from the expected rate of return of the portfolio? So 7.5% minus 11.7% equals negative 4.2%. 12% minus 11.7% equals 0.3%. So you do that all the way down. You find the deviations, you square the deviations, and you multiply them by the probabilities, which I relisted here. Sum up these probabilities. That gives you the variance. So you take the square root of the variance, and that gives you the standard deviation. And I don't have the coefficient variation formula anywhere, but as you recall from 302, coefficient variation is risk per unit of return. So you take your portfolio standard deviation divided by your portfolio expected rate of return, and that gives you the risk per unit of return. So this portfolio has 0.23 units of risk for each unit of return, so pretty low.